Good morning, folks. Today we're going to update last night's video on the big solar flare that erupted and triggered a proton storm at Earth. We'll take a peek at the CME trajectory with updated coronagraphs and Enlil spiral, and then we'll hit a good paper that we saw as a preprint but is now officially in the journals. This is what we saw last night. A multi-phase eruption triggered by the destabilization of a plasma filament, with plasma then raining back down and triggering subsequent, larger eruptive activity. Unlike most of the flares we've had for a while, it was not a brief, impulsive solar flare, but a long-duration event, the kind that always indicate a bigger CME eruption. The placement of the solar blast on the departing limb means it had a higher chance to impact the magnetic connection between the Earth and Sun, and that is exactly what happened. The energy from the blast surged the magnetic fields, accelerating the high-energy protons of the Sun to the Earth and triggering that level 2 proton storm. Luckily, the event did not get much worse than we saw last night and remains at level 2 here this morning. The coronagraphs are pretty well updated now, with both C2 and C3 cameras, indicating that this wide burst does have a very good chance of impacting the Earth here in the next 48 hours or so. It should almost certainly produce a geomagnetic storm, but the M class of the flare and the fact that it will not be a direct hit means there is virtually no chance this is the big one we're worried about from the Sun. Still, a harsh reminder of what our star can do. Last night I mentioned the tsunami of fire created by the eruption, and you can see it most clearly here on the near side as the plasma wave coming towards the camera on the solar surface. It was visible in every wavelength, but clearly able to be seen here in the combined 171 and 193 angstrom views. Several times larger than our planet. Gorgeous. Taking a quick peek at the paper we mentioned, we saw it a couple weeks ago, but now it has hit the journals officially. The ibex ribbon changes over an entire solar cycle, and we're not talking sunspot maximum versus sunspot minimum, but similar stages of the cycle so that those comparisons are legitimate. This is more change than expected over such a short period astronomically, and as we said when the preprint came out, it's likely due to the interaction with a galactic current sheet, the element shifting our entire solar system, including the Sun.